And today I think is the 24th. I think. Thank you. Okay, so any questions? Any questions for me? So 2.3 and 2.4 talks about lines. And let's refresh our memory on everything we know about lines and then work on problems. We already refreshed our memory on two equations. We said y equals mx plus b. What did this represent? Slope-intercept form. And when we say intercept, we really mean y-intercept. It's kind of confusing, but we mean y-intercept. Then we had y minus y1 equals the slope times x minus x1, and we know this is the point slope form. Very good. We did that last time. Now let's refresh our memory on different types of lines. There are 4 types of lines. The other thing that we used last time was the slope given 2 points. So if we're given 2 points, how do we know how to determine the equation, the slope of the line passing through those points? We know it's rise over run. By rise, we mean the difference in y values. And by run, we mean the difference in x values. Very good. Okay, these are types of lines. Types of lines. There are only 4 different types of lines. Can anyone give us the slope of this line? Thank you. The horizontal line has slope 0. Can anyone give us the slope of what type of line is this? Vertical line. What is the slope of a vertical line? Thank you. It does not exist. We like to say undefined, but it does not exist. Very good. What type of slope is this? Not the exact number. What type? Is it positive or negative? Yes, this is positive every time we see a line that goes from negative values to positive values. The slope is always positive. If we see a line that goes from negative values to positive values, what type of slope would that be? Very good. We also have parallel and perpendicular lines. Parallel, perpendicular. Parallel and perpendicular lines. 2 lines are parallel. So this is a line, this is another line, this is the slope. The slope of the first line is called M1. I decided to call it a slope of the first one, and this is M2. What is the relationship between the slopes of 2 lines if they are parallel? Very good. So M1 indeed must equal M2. What if 2 lines are perpendicular? Meaning they are forming 4 90-degree angles. So this is the slope of the slope of the first line, and M2 is the slope of the second one. So, what is the relationship between the slope of these 2 lines if they are perpendicular? Negative reciprocal of each other. So M1 equals the opposite of 1 over M2. If M2 is 5, how much is M1? If M2, negative 1/5. If M2 is negative 1/2, how much is M1? You have to flip. If this is 1/2, when I divide by a fraction, I have to flip the fraction. And what do I get? But I cannot have both negative if this is negative 1/2, right? So one more time. If M2 equals 5, then M1 equals negative 1/5. If M2 equals negative 1/2, then M1 equals 2. It is easier, in my opinion, you choose which one is best for you. It is easier to remember that M1 times M2, if you cross multiply, we've done this before, when we cross multiply, M1 times M2 must equal m1 times n2 must equal, what is here under m1? 1. So how much is this? Exactly. This is the way I like to remember it. Because now I think it's easier if you say to me, m2 is 5. 5 times what is negative 1? Well, it has to be negative 1/5. If you say m2 is negative 1/3, then obviously this has to be 3. But it doesn't matter. This relationship is identical with this one. It looks differently, but it's identical with that. By simply cross multiplying, because this is a proportion. And we know that only in a proportion we can cross multiply. Okay, so let's look at a few examples and move on. Maybe even graph a line. So in 2.3 on page 267, let's say problem 31 on page 267. Let's say we are given negative 3 comma negative 2 and a point 3 comma 6. We're asked to find the equation of the line. Find the equation of the line. Find the equation of the line passing to the given points. What do I have to determine first? What is my starting point? Yes, thank you. Agreed? Now you have to decide which one is the first point, which one is the second point. It doesn't matter really. x1, y1, I call them as the first point, and then x2, y2 as the second point. So this is 6. So now I have to be very careful. I recommend always write the definition, so you don't make a mistake. Always write y2 minus y1 over x2 minus x1, and you will never forget it. So then carefully plug it in. Can anyone give us the plug-in? Very good. And I omit that because I will have parentheses and parentheses. And the denominator is 3 plus. Very good. So this 8 over 6, I have to simplify it, which is 4/3. Now remember, we have two options. We have this option, and we have this option. I will use this option only if one of the points is 0 comma a number. If I do not have 0 comma a number, I don't have the y-intercept, and I will not use this. I will use this. So I'm looking first to see if I have 0 comma a number. No, I do not have 0 comma a number. These two ordered pairs are not the y-intercept. So therefore, I'm going to use y minus y1 equals the slope times x minus x1. I'm sure you're thinking which point to use. It doesn't matter. If I use the first and you use the second, we'll get the same equation. So far, so good? So which point do you prefer? If you choose this one, is nice because these will turn into positives. If you choose this one, they will stay as they are. It doesn't matter really. Number 1 or number 2? Number 1. So then carefully replace. I replace them underneath so I don't mess up when I replace. So first I write here under y1, I write negative 2. And here under x1, I write negative 3. And I write 4/3 under the slope. And then I put everything together. So then y plus 2 equals 4/3 parentheses x plus 3. I do have to solve for y. I will be distributing and then subtracting 2. When I distribute 4/3 to x, I get 4/3 x. When I distribute 4 over 3 to 3 over 1, what do I get? 4 over 3 to 3 over 1. Always simplify before you multiply. Yes, or you simplify and you say 4, right? So plus 4 and then minus 2. It's not a mistake to multiply first and then simplify. I think it's easier to simplify before you multiply. So then the equation becomes y equals 4/3 x plus 2. Can anyone tell us what does this represent in the context of the problem? Correct. It means what? This is the equation of the line passing through the given points, right? And now I can also determine the y-intercept. Can anyone give us the y-intercept? 0, 2. Very good. 0, 2. Okay. Let's look at graphing a following equation. So let's say problem 70 on page 267. Graph. So we have 4y. I'm sorry, I'm copying from something else. 4x plus 6y plus 12 equals 0. Sorry about that. I copied 62 instead. My apologies. So 62, 4x plus 6y plus 12 equals 0. We are asked to graph this function. I know in the past you will probably solve for y and find the slope. No. There is no need to do anything. Okay. Now, if we look at a coordinate system, and I say to you, here's a graph of a line. How do we call this point? Very good. This is called the X intercept. For a function is also called the zero of f of x, or the zeros if it has more than one. Perfect. How do we call this point? Very good. Now, how do I determine the x-intercept? It's a point on the x-axis. What is the equation of this line? It's a horizontal line. So what is the equation of the x-axis? Perfect. So all points on this line must have y equals 0. Perfect. What about this line? What is the equation of the y-axis? It's a vertical line, right? Perfect. X equals 0. So then all points on this line must have x equals 0. So this is exactly what we're going to do with this equation. I'm going to copy it on my next page. So 4x plus 6y plus 12 equals 0. I'm going to set x equals 0 and find the corresponding y. And then I'm going to set y equal to 0 and find the corresponding x. I'm not going to waste my time solving for y. I'm not going to waste my time moving terms around, dividing. There is no need for such operation. So here's how I proceed. X equals 0. I go back to the equation. I simply cover it because this goes away. Can anyone give us how much y should be from this? Y should be, of course, you will have to move 12 to the other side. Imagine that you move it to the other side, it becomes opposite, and you will divide by 6. Negative 2. So what is the ordered pair that we just determined? Do you all agree with 0, negative 2? What do you think I'm going to do now in order to determine the x-intercept? I'm going to exactly cover this. It's gone. Now I have 4x plus 12 equals 0. How much is x? Well, yes, because you have to imagine that you're moving 12 to the other side and divide by 4. Okay? This is something we did last month. So the ordered pair will be negative 3, 0. So now I'm ready to graph. I will plot 2 points, negative 0, comma, negative 2, which is this point, and I will plot negative 3, 0, which is this point. I connect the points, extend the line. I always write the equation of the line somewhere near the line. Anywhere you want, above, below, left, right, doesn't matter. So I'm going to write 4x plus 6y plus 12 equals 0 because this is what I graphed. And this is the equation. This is the graph of the equation we were given. Any questions? Any questions? Okay, I would like us to work on another problem. On page 279, problem 5. Let me ask you again, do you have any questions on graphing using X and Y intercepts? Any questions? Do you think we need more examples, or are we comfortable with this? Please speak up and don't be shy, because I don't know, I don't want to leave anyone behind. Okay, so in problem 5, we are asked to find the equation of a line passing through -8, -10, and parallel, this is the symbol for parallel, to the line whose equation is y equals -4x plus 3. So let me give you the setup one more time. We're asked to find the equation of a line, seen here in red, and we know two things about it. We know that it passes through the point -8, -10, and we also know that it's parallel to a line whose equation is given to be -4x plus 3. This is not the actual graph, this is just the idea. Obviously, this is wrong, right, the way I graphed it, because this has a negative slope, and I should have graphed it like this. But this is not a graph of the exact graph of the function of the equations given. This is an idea. This is just to see what needs to be done. So I have this equation whose equation I don't know, and I know I'm given two pieces of information. One piece of information is that there is a point that it passes through. The other piece of information is that the line that I would like to determine the equation for is parallel to this line whose equation is given. So because I have a point that is or is not the y-intercept, is not, I will have to think of y minus y1 equals the slope times x minus x1, in which I have x1 being -8 and y1 being -10. But I am missing, so far, I am missing a big important part of the puzzle. But the question now is the slope of this line somehow given indirectly? Is not really thrown? Yes.
In order for them to be parallel, you have to have the same slope.
Very good. So then I have to determine the slope of the blue line. Can anyone give us the slope of the blue line? And how do I determine that? Remember, I compare it to y equals mx plus b. The slope is only a number. Never say that the slope is 5x. The slope is only the number in front of x, the coefficient of x. So comparing this to this, I can clearly identify the slope, which is, do you all agree? So then the red line must have, since we know they are parallel, must have which slope? Do we all agree with -4? All I have to do is just plug it in, and I'm done. So I determine the equation of the line passing to the given point. I'm not there yet, but I will be determining right now the equation of the line passing to the given point and parallel to the given line. So then y, oops, I didn't mean this, sorry. So then y plus 10 equals -4, x plus 8. I distribute -4x, -32, minus 10. So the equation of the line passing through -8, -10, and parallel to the given line is, of course, it has to have -4x, and that's -42. Any questions? Now let's do the same idea, but this time instead of parallel, what do you think? The lines will be perpendicular. Yes. Is this okay? Any questions here? Any questions, Danielle? Any questions? Everything okay? Okay. Good. So let's look. I know I'm chilly too. It's on max heat. I'm not sure why. Okay. So number 11. I don't know if you're cold. I'm sorry about that. So 4, -7. So the line this time passes through 4, -7, and is perpendicular. This is a sign for perpendicular lines. to x minus 2y minus 3 equals 0. Again, I'm not graphing anything exact. I'm just giving you the idea. So there is a line whose equation I have no clue about, but I do have two pieces of information. One of them is that the line passes through 4, negative 7. The second piece of information is that this line happens to be perpendicular, creating 4 90-degree angles perpendicular to a line whose equation is given, which is x minus 2y minus 3 equals 0. Again, the same question. Find the equation of the green line, of the red line, sorry. I had green and I wanted to use green, but I used blue. Okay, so this is our unknown. We know that it passes through 4, negative 7, and it's perpendicular to this line. Do I have the y-intercept? No, because this is not 0, a number. Again, I have to think of the point-slope form. X minus x1 equals the slope times x minus x1. And now I have the 4 and I have the negative 7. The only question is, what do I do with the slope? How do I determine the slope? It's not given to us directly, but somehow it is. We can determine it. So how do we do that? Exactly. I have to solve for y. See the difference here? This equation was already solved for y, and it was easy to identify the slope. But if I don't solve this equation for y, I will not know what the slope is. So I have to solve for y in order to put it in this format, the slope-intercept form, so I can read the slope. So let's do that. So I have x minus 2y minus 3 equals 0. What is the first step towards solving this for y? So if you want, yes, that's fine. So then I have 2y equals x minus 3. Perfect. That's awesome. And I can read from the right or I can read from the left. It doesn't matter. Awesome. So I move 2y to this side, and then I have x minus 3. One more step. And this time I cannot, and I should not. Please do not do this. It will be difficult to identify the slope. Divide both sides by 2, term by term. 2y divided by 2 is y. X divided by 2, it's wise to write it 1/2 x. It's the same thing with x over 2. 1/2 x. And then minus 3 over 2. So now I can identify the slope of the second line. What is it? 1/2. 1/2 is this slope. M2 equals 1/2. Then I do know M1 because I know the relationship. Their product of M1 and M2 must equal -1. Or you say M1 is -1 over M2. Whatever you say, the answer will be the same. So what is M1 equal to? Very good. Why? Because the product of these two numbers has to be -1. So now I have the slope, which is -2. All I have to do is just plug it in, and I'm done. So then I have y plus 7 equals -2 and x minus 4. I distribute -2x, and this is plus 8, but I'm bringing a -7. So then I have -2x plus 1. Can anyone say or tell us what is this? Y equals -2x plus 1. What does it mean? It's the equation of the line passing through 4, -7 and perpendicular to the given line. X minus 2y minus 3 equals 0. So it's the red line. It definitely passes through this, and it's perpendicular to x minus 2y minus 3. That's x equals -2x plus 1. Any questions?
So would 0 plus 1 be where it intersects?
Exactly. 0, 1 is the y-intercept. Yes.
The
So-
y-intercept of,
Of this line.
yeah, okay.
not of this line. They cannot have the same y-intercept. So imagine the coordinate system. So this will be the y-intercept here, and this will be for the other y-intercept. We can, if you want, we can graph both on the coordinate system, on the same coordinate system with the graphing calculator, and you'll see that they have to have different y-intercepts, as well as parallel lines. Even parallel lines have to have different y-intercepts. Very good. Any questions? Okay, one last topic in this section is what it's called the average rate of change. Any questions? So let's suppose we have a function. Any graph, you can graph anything you want. I'm going to graph this. And I want to determine the average rate of change, how much it changes averagely, if you want, between this point and this point. I'm going to call this x1. This is our function f of x. Can anyone tell us what this is? If this is x1, what will this be? Very important. That's a super important concept. Thank you very much. If this is x2, what is this? Very important to remember that. What is this value right here? F of x2. Good. So now you also know that the coordinates of this point, let's call it A, will be x1 comma f of x1, of course, and the coordinates of B will definitely be very good, comma, very good, awesome. The average rate of change, I will say the average rate of change between x1 and x2 is this, well, I hope it doesn't show when I scan it. Okay, so the average rate of change between these 2 points is nothing else but f of x2 minus f of x1 divided by x2 minus 1 is the slope of the line AB. Nothing else. So let's determine the average rate of change of a function between 2 points. Let's look at problem 15 on page 279. So if I want to determine, for example, let's say you call me, I'm driving to New York, and an hour or 2 hours before I start from Baltimore, you give me a call and you say, what is your speed right now? I will look at the odometer and I will say 65 miles an hour. But that's the instantaneous rate of change. Okay? This is not what we're trying to determine. But if you say to me, okay, yesterday you drove to New York, you started in Baltimore, and you ended up in New York, fine. Tell me, what was your average rate of change? What your average rate of speed, or what is your average speed? Then I have to calculate this. You may say, I don't want to know your average rate of speed, average rate of change, or the speed between Baltimore and New York. I wanted to know it from Wilmington, Delaware, and Brooklyn, New York. Then I have to look at the time. That will be the x. And I have to look at the speed I'm driving at. And I have to, calculate the distance that I'm away from home, and subtract those 2 distances, and subtract those 2 speeds, and those 2 time frame. So this will be the distance from home when I am driving through Brooklyn. This will be the time, assuming I do not stop, the time that I needed to get from Baltimore to Brooklyn, minus the distance away from home when I'm going through Wilmington, Delaware, over the time that I used to get to Wilmington, Delaware from Baltimore. And this answer will be this. I will tell you exactly my average rate of change between these 2 locations. Okay? Distance from home minus distance from home over time from home minus time from home. So now we're given a function that is a quadratic function, f of x equals x squared plus 2x, and they're giving us x1 equals 3 and x2 equals 5, and they want us to determine the average rate of change of this function, which could be distance, which could be profit, which could be cost, who knows. We're asked to find the average rate of change between 3 and 5. I will write always the definition first so I don't forget what I'm doing. It has to be f of x2 minus f of x1, like in my case, a difference in distance, over the difference in time. Difference in distance over difference in time, which will give us the average rate of change, the average speed. Okay, so can anyone give us the denominator first? What will you write for the denominator?
5 minus 9.
That's very clear. What will you write for the numerator? And you should say, I don't have it yet. Give me a second. What do I have to do?
Look at the x values.
Very good. I have to find f of x1, and I have to find f of x2. In other words, I have to find f of 3, and I have to find f of 5. Can anyone give us f of 3? Very good. Do you all agree with 9 plus 6 for f of 3? 9 plus 6 equals 15. And what about 5? 25 plus 10? 35. Do you all agree with 35? Any questions? We plug in 5. 5 squared is 25. 2 times 5 is 10. 25 plus 10 is 35. Is that okay? So then what do I have at the top?
35 minus 2.
So then the top will be 20. The denominator will be 2. Now I can simplify, not otherwise. So the answer is 10. Now, in the example that I gave you with distance and time, what will 10 have as a measurement unit? Remember, it's a ratio. If it's a ratio, it has to be a ratio of 2 measurement units. One coming from the top and one coming from the bottom. If the numerator is measured in miles and the denominator is measured in hours that I use to drive, what will be 10? Miles per hour. Exactly. Okay, this completes everything except section 2.5 that we are going to start right now, which is the last section before the test. Section 2.5, you may think that it's useless. I would say it's a very important skill. Like, for example, when we look at a function that is, let's say, 2x plus 1 over 3x minus 3, what does this mean? Well, this is what it means. It means 2 multiplied by whatever plus 1 over 3 multiplied by whatever minus 3. So this is very useful to be able to look at a function and understand the pattern. The same thing with section 2.5, which is called transformations. You could say this is useless, but I will say it's extremely useful to be able to look at a function and say, I know what this tells me. Not just that it tells me the pattern, but I know how it looks. And you will see that it's not going to be a difficult task if we understand what is called the base functions. So we have to have some information. We have to have some rules before we build these transformations. Okay, so here are what I like to call base, or if you want basic, whatever you want, base or basic functions. In other words, the baby steps. If I can't stand up, I can make a first step and the second step, right? So this is a standing up. I need to stand up in order to make steps. So what are those functions? The simplest possible functions on the planet from different categories. I'm going to start with polynomial. We have several in polynomial. We have linear We have quadratic. We have cubic, which we will deal a lot with in the next chapter. We will have fourth degree, which we'll deal with later in chapter 3. And I can go on forever, but this is all I need from polynomial. Now, so let's look at a linear equation function. Can anyone give us the simplest possible linear function? The simplest. There is nothing simpler than that particular linear function. F of x equals just x. You're right. X plus 2 is also simple. But the simplest possible linear equation is y equals x. Here is the graph of y equals x. The simplest possible linear function. F of x equals x. Is it odd, even, or none of the above? Very important to know. If it's even, it has to be symmetric with respect to the y-axis. What I have in the first quadrant, I have to have in the second quadrant. Is it that case? No. So it's odd. It is odd because what I see in the first quadrant, I have a copy in the third. Symmetric with respect to the origin. Very good. The next simplest possible polynomial, so for the quadratic. So we have to remember this graph. For quadratic, f of x equals the simplest possible quadratic function that no one can find another. That's it. So here is x squared. Okay, so let's graph it. Again, we'll review it in the next chapter. So this is f of x equals x squared. We know this, we've seen it before, it's not new, but we will review it. So can anyone tell us if this is an odd, even, or none of the above? Perfect. It is an even function because the graph is symmetric with respect to the y-axis. Even indeed. Okay, next one. The cubic. Can anyone give us the simplest cubic function? No one can find a simpler cubic function than this one. X cubed. We are going to see it many times in the next section. And here is its graph. In the next chapter, I meant to say. Yes, we need to remember this. Odd, even, or none of the above. And this is the function we use to illustrate. It is odd, symmetric with respect to the origin. Very good. Last one, fourth degree. Fourth degree, f of x, of course, x to the fourth. Again, we will see it again and again, several times in chapter 3. So here's the graph. Very, very similar to the graph of x squared, as you see. But this one turns much faster than this one. This is a little bit flatter here. So this is f of x, x to the fourth. Okay, so can anyone tell us odd, even, or none of the above? Perfect. Even it is. Okay, these were polynomials. Degree 1, degree 2, degree 3. Now, let's look at a few more. So you tell me what type of function this is, and I will put the name that you give me right here. Of course. Once I read it, I know what it is, right? So we graphed this function a long time ago. We also say that it looks like a what? Very good, awesome. It does look like a V. So this is f of x equals the absolute value of x. Odd, even, or none of the above. Perfect. Even it is. Okay, next one. I'm going to write f of x equals the square root of x, and you'll tell me. Sorry, I read it for you. So what is it? Square root. Okay, here's the graph. And then we can talk about transformations. So this is f of x, the square root of x. We can also picture the cube root of x. Let's do that too. Odd, even, or none of the above? Not symmetric. Very good. This is not a symmetric function. It's not symmetric with respect to the origin. It's not symmetric with respect to the y-axis. Not symmetric. And just one more, promise, last one. The simplest possible, what? Very good. Here's the graph. These are simple possible functions, the simplest possible functions for different categories. And at some point in time, we should have remembered these.